Harold here. Today I want to talk to you about a Python module called heapq. Uh, First, I need to explain what a heap is. In most data, it's just an unstructured, unindexed pile of data. Uh, Python is a special kind of binary tree. We think of it as an upside down family tree. And it's usually used for priority queues. And what it does is it always has the smallest number at the top. And that makes it super fast to get or remove the smallest item from the queue. Uh, Python gives you a built-in module called heapq, and it lets you turn a list into a heap. Key rules: the smallest item is always at index 0. When you add, push, or remove pop, Python rearranges the list to keep the heap rule true, so whatever is the minimum now goes to the front. So create a heap, there's two methods. You can push to an empty list. So I have an empty list here called nums. I've imported heapq earlier. You can import each of these methods from heapq, import heappush. I just import heap. I think it gives your code better readability that way. So heapq.push heappush to nums2, and then I'm going to push 1, 5, 4, 3. So the first one pushed should be 2, 1, 5, 4, 3. This will create a heap with the smallest value at index 0, even though we pushed 2 before 1. So let's create an empty list, push our numbers. So what is it? Nums, we'll call nums 1, 2, 5, 4, 3. So our order of entry was 2, 1, 5, 4, 3. It just pushed the 1 to the front. It doesn't care about any of the rest of the order. It's 1, 2, 5, 4, 3 now. And you can check indexing. 0 is 1. The other way to create a heap is turn an existing list into a heap. So I'll use the same nums2 though. Nums2 equals a list 2, 1, 5, 4, 3. And nums2 0 is 2. But if we heapify, so we say heapq.heapify nums2, this will create a heap with the smallest value at index 0, even though the original list had 2 before 1. So nums2, 1, 2, 5, 4, 3. 1 is now at the beginning. Nums2 at index 0 is 1. This works with strings too. So I have a list of people: Sue, Jorge, Anisha, and Rajiv. So I'll say heapify people, and then print people. And Anisha's now moved to the front. Jorge, Sue, and Rajiv are just in whatever order, random order it chose. You want to put a new item. We've already seen push, but here's a new list, nums3. I'm going to heapq.heapify nums3. So it should put the smallest value, which is 7 at the beginning. So 7. The rest of it didn't care, but it puts 7 at the front. So I'm going to push heapq.heappush to nums3, takes 2 arguments, the heap, and what number you want to push. So we'll do that and push. So num3 is now at index 0. So 3, 7, 25. Didn't care about the rest of the order when I push 3. It Check was all the rest of them, slower than all the rest of them, put it at the front. Um, remove the smallest item in existing heap is heapop. So that should take a 3 off. And you see we're back to the 7 being in the beginning with the rest in whatever order it shows. You can do this operation at the same time. Heap push pop will insert a new number into nums3 and take out the minimum. So nums3 is now 25 is the minimum and 87 has been inserted. You can do the same thing with heap replace, but there's a small difference. I'm going to say heapq, heap replace, heap nums3. I'm going to replace 27. That should put 27 in and pop the lowest number, which is 25. So it popped 25, and now 27 is in my array, 25 is not. The difference between heap push pop and heap replace, push pop first pushes the item and then pops the smallest item, which could be the item you just pushed if it's the smallest. It's equivalent to heap push followed by heap pop. Heap replace pops first, then pushes. It's equivalent to heap pop followed by heap push. It's useful when you want to replace the smallest item with a new one. So short heap push pop is pushed and pop, and heap replace is pop and push. I hope you got all that. Play around with these, it's kind of fun. Some useful convenience functions it has is you can return the n largest items from the heap with n largest, the number you want to return, and your heap. So the largest three numbers in my heap are 90, 89, and 87. Yes, correct. And smallest three. You can use whatever number you want. So 26, 27, 31. I could have said 2, 26, and 27. Uh, now that you understand the heap and its functions, let me give you a good use case for it to finish this up. So say you got a heap of data that's ready for processing and your processing order is minimum first. So you want to pull the next item from the heap for processing. So here's your list of jobs, tasks, 31, 42, 18, 27, 34, 22, and 8. 8 would be the minimum. We're going to turn that heap into heapify, ready to process. And we'll write a little function. To define pull item, the only argument it takes is a heap. We'll set item number to 1. And while the heap has something in it, we're going to pop an item. We're going to print item number, processed, an item. So it'll say item 1 processed and then give the item, which is the number up here. And then we'll add item number plus equal 1 and keep looping until the heap is empty. And then we'll print job complete, the heap is empty. So let's pull item ready to process. So it's going to run through a loop, process these items in order with a minimum, process these items in order, pulling the minimum to the front for processing each time. So let's run this and we'll call it pull item in our heap ready to process. So item 1 processed 8, 18, 2, 322, 427, 531, 634, 742, and the job complete, and the heap is empty. So if they were all jumbled up in there and you wanted to process them minimum first, heap is beautiful. I think this is a pretty cool data structure you may not have known before, and I think you now may be able to get some use out of it. I hope you can. I hope you like this video, and I'll see you next time. Thanks, everybody.